Hello everyone, welcome back to the another session in design and analysis of algorithms. Topic name is optimal binary search tree. This video continuation part of the last video of optimal binary search tree. So in that video we covered what is binary search tree and optimal binary search tree. So this video will be going to cover how dynamic programming can be applied on this optimal binary search tree, and we'll take some example of previous question papers and we'll solve it. So I advise all the students who are watching this video has to watch the previous video as it is a sequence. Let's get started. So before of this video, we were discussed about this example that I have taken 4 keys to find it out what is the cost of it, correct? So now the way how I proceeded is once I given with the number of keys and name of the keys, I started to found how many binary trees I'll get, the possible number of binary trees I'll get. For that also we were taken the formula in the previous example that 2ncn by n plus 1. With this formula we were found that 14 possible binary trees will get. If keys are into 5 proportional to the number, we will see the more number of binary trees. If it is 6, again you will have more number. If it is 7, again you will have more number. So for all these 14 trees, you cannot find out the cost. And this cost, what I have taken this formula, this cost is for existing binary search tree. That when you given with keys and when you given with a tree, then this is the formula to calculate what is the cost of binary search tree. But now this video will be going to take only the keys and the probability of successful search and unsuccessful search. We'll take only these things and we'll construct the optimal binary search tree. Find the difference. If you have a tree, then you can calculate the cost of it. If I don't have a tree, then also I'll have a formula, because keeping in mind that our element of the key. Now look at this example. This is 1 and this is 2, this is 3. Now here root element is 20, right? And so I'm just assuming k is key element. Now here key element is, here k value is what? 2. Let's suppose 1, 2, 3, 4. Now the root element is what? 2 element. Second key element was at root position. Now the same root element in one tree that was appeared at left child of other tree, correct? And if you can see here also that 20 is here. So point is what? In every tree root element will get change. For every tree cost will be differ. For this tree we got 2.1 and it is not at all sure that you will get the same 2.1 over here and you will get the same 2.1 over here. For sure it will be not 2.1, not 2.1. So the point is, for every tree you have to calculate the cost of it and you have to find out the minimum cost which is producing, the binary tree which is producing. So this is what actually our task. But the very big problem is you cannot consider all the 14 trees to draw and to find out the cost. So that is the reason we'll apply dynamic programming approach on this problem. So as far as dynamic programming methodology or approach is considered, we'll take all these 14 combinations, all these 14 possibilities, not direct way but indirect way we'll take, and we'll see that for which k element you will get the minimum cost, right? Now we'll take an example and we'll move. So this problem is, I did not have any tree, I have only the keys. I don't have any tree as I have in the last example. This example I just given with. Now that is the reason I once again remind you the definition of optimal binary search tree. The definition is what? A problem OBST, optimal binary search tree, is that if the key is given, yes, we'll have keys. If the key is given and the probabilities P and Q is given, we have to generate a binary search tree. Who has to generate? We has to generate. So to generate the binary search tree, you have a formula. So according to this formula, we'll calculate for all the possibilities, and whichever is minimum, that it will be taken. Now you have to calculate the cost, and also there is a term which is W. W refers to weight of your I comma j. Let's suppose that also we'll see in the next slide. Let me finish this cost. So cost can be calculated using of this formula. Now let's focus at the formula is what? Minimum of 1 I less than k less than or equal to j. C of I comma k minus 1 plus C of k comma j plus wi comma j. Now the mean of this is, we will be going to compare cost of 2. The 2 is what? Let's suppose that my k value is 1. My key value is 1. So now among my 4 keys, I have chosen the first key should be at the root position, that k is equal to 1. So my first element is in the root position. Then we will be finding out the cost in between of the first element, that the before element and the present element. Okay. Now whichever is minimum, that will be calculated with this wi comma j. We'll take an example and we'll move little more further. I wanted to calculate C cost of 0 comma 3. Now what k values are possible here? K, when you took 3 nodes, now 3 nodes, k is equal to 1, k is equal to 2, k is equal to 3. For these 3 possibilities, you have to check the cost. That's what C 0 comma 0. That means this is my k is equal to 1. So when k is equal to 1, my I value is 0 over here. It is I and this is j. According to the formula, this is what I comma k minus 1. I is what? 0. K minus 1. My k value is 1. 1 minus 1, 0. It is what? C of 0 comma 0. Now, plus C of 1 comma 3. What is this 1? K value. 3 is what? J value. So, this is what? The cost when my key, first key is in the root position. And this is what? C of 0 comma 1, C of 2 comma 3, this is what k is equal to 2, and this is what k is equal to 3. For all the possibilities of k, will be calculating the cost. Whichever cost is minimum among these 3, that will be considered. Right? Now, the other point is what? If you can see this one, again, we do have C 2 comma 3. If I wanted to get C 0 comma 3, I have to know what is C 3 comma 3. The upper value. I am at 0 comma 3. I have to calculate 1 comma 3 if I wanted to get 0 comma 3. Yes, I am at 0 comma 3. But in 0 comma, to get the value of this, I should know 1 comma 3 value, the next value. I should know 2 comma 3 value. I should know 3 comma 3 value. So what we are going to do is, we will do the reverse process. That will calculate the higher terms first. When you get these terms, these costs first, it will be very easy for us to get the lower values. Yes? Now, that's the reason we are just making our methodology little more simpler, that is these formulas. Look at this. J minus, we are calculating Ci comma j. When we are supposed to calculate Ci comma j, there are terms which are producing the bigger values, right? So that's the reason I'm just making formula very simplified. That is, when j minus I is equal to 0, that the j minus I is equal to 0 is what? When j minus I will become 0, for these cases j minus I will become 0. Keeping in mind this is I and this is j. J minus I 0. J minus I 0. j minus I 0, j minus I 0. For all j minus I values, we'll calculate first. The cost of these will get evaluated first. Then we'll come down for whose values j minus I is equal to 1. For that values we'll calculate. Now, the last you will be calculating C of 0, 3. When you calculate this, all the terms which are higher to that are evaluated first. So it is easy for us to get the value of this. So that is the reason why we segregated according to this logic, right? Now, so this is about cost. Cost of 4 keys depending upon k possibilities. Our k value lies from 0 to 4 or 1 to 3. Now, we should know weight because cost is included with wi comma j. So you have to know what is wi comma j now. So wi comma j formula is what? W of I comma j, wi comma j minus 1 plus pj plus qj. When you wanted to know the weight of one node or one key, you should even add the probability of successful and unsuccessful. Then you will be come to know what is the weight of the particular key. Now let's suppose what is the weight of 0 0 w00. It is 0 itself. w1 comma 1. w1 comma 1 also 0. Why it is 0? Look at the formula. Now I'm just elaborating the formula. What is I? 1. 1 comma. What is j minus 1? J minus 1. 1 minus 1 is 0 plus pj plus qj. What is pj? Pj is probability. Now we will be given with. That's what I have given the definition of OBST in the last slide. OBST example is what? We will be given with keys and the probabilities. Then only it is possible for us to generate optimal binary search tree such that the cost will be the minimum. Fine. Now according to this we'll bit move.